let's take a look at an example of a special trigonometric limit. I'll do a couple of these. For one, we have a theorem that's outlined in, the proof is outlined in your text, that the limit as x approaches 0 of sine of x divided by x is 1. Now, what I need you to understand here is, let's make that a little more clear, that sine of x over x is never actually equal to 1, but around 0 it limits to 1. And the function, if you graph it with your graphing calculator, has this dampening effect, and it is symmetric about the y-axis. And so this y position here is a hole at 0, 1. The function is not defined there, so it is discontinuous at x equals 0. But if for a moment we can accept this theorem, then we can handle examples like the following. A couple ways you can think about this. One approach is to realize that sine of 2x is an actual identity called a double angle identity that you've seen before in trigonometry. And then you can notice that the x in the denominator is approaching 0, which prevents you from using the quotient law. However, if I do a little algebraic finagling here, we could see that this product of three terms is actually the same as the previous quotient. And in this regard, we do have limit laws to support breaking this into a product of limits if we accept the above theorem. Now, we talked earlier about when you can substitute when you have a limit law. This first limit is the constant law. The second limit is the special trig limit. And the last guy is the substitution law, because we said that cosine of x is a nice function. Therefore, the limit and the function value are the same. In other words, therefore it is continuous. And so overall, we have this guy having a limit of 2.